There are several landforms such as deltas that develop at the mouth of the rivers. River action is clearly visible on the deltaic coasts. Since rivers bring fresh water and sediment, their role is important, particularly in estuaries and deltas. The sediment brought by the rivers are an important addition to the coastal sediment budget, which are significant for shifting of beaches and dunes. In deltas, the sediments brought by rivers are generally deposited at the mouth of the river, which are then redistributed by coastal processes, whereas in the case of estuaries, it acts as a sink for both fluvial and nearshore sediments. Biological processes. Plants and animals are also the agents that play important role in shaping up coasts. Biological processes are dominant on many coasts as plants trap sediments and also help in binding them, e.g. on coastal dunes, mangrove coasts, algal mats, etc. In case of dunes, vegetation binds sand, and on muddy coasts, algae, mangrove and marsh vegetation trap sediments. Another very good example is the coral reefs, which are the landforms generated by almost entirely by organisms. The reef framework is built by the corals and is contributed by other organisms that graze, bore and contribute sediments for infilling and binding the reef. They help building new lands on the coasts. Coral reefs are very important due to their ecological and economic importance. Another most influential factor is human, who can drastically modify a coast. Impact of human activities on coasts is now well documented. Hill slope and glacial processes. Besides wind action, there are other subaerial processes that can be important in certain coastal settings such as hill slope, particularly on rocky coasts. Nature of slope and the material it consists of could vary greatly from one. 13. Environmental geology. Place to another, hence affecting the generation and movement of materials. Similarly, processes associated with ice and frost may also affect coastal configurations. However, these actions are restricted to high-latitude coasts. 5. Coastal processes and their distinctive features. In this section we will study about the erosion, transport and deposition mechanisms of these processes and also the distinct features they develop. 5.1 Erosional processes and resulting landforms. Although erosion on coasts is a natural process, the rate of erosion is accelerated by tsunamis, storm surges and also human activities. Erosion on coasts depends on several factors such as nature of coast, nature of rock, presence of joints and fissures in the rocks, presence of rock articles with waves, chemical action of seawater, and also wave strength. Erosion is prominent in coasts where waves are not obstructed and dash directly, whereas in shallow low-lying coastal plain, waves are obstructed before reaching shore, thus resulting in reduced impact of waves. When waves dash against the shore, rock fragments present with waves also dash against the coastal rocks and wear them off. With the presence of dissolved materials, seawater becomes better solvent, thus enhancing chemical action on the coastal rocks. It is obvious that erosive action is more when wave strength is more. Erosion on coasts takes place by the following mechanisms. Corrosion. It is process of chemical weathering by which coastal rocks, e.g. limestone rocks, change, degrade into more chemically stable form, such as its oxide, hydroxide, or sulfide due to pH of seawater. The soluble rocks, or parts of the rocks, are dissolved. The rate of reaction is further increased by wave action, which continuously removes the reacted material. This process is not considered very significant because its influence is restricted mainly to limestones or other similar rocks. Corrosion or abrasion. It is the mechanical process and is considered as the most important process of erosion. When waves pound coasts, the rock fragments, sand, pebbles and boulders, present in the coasts act as tools of erosion as they break pieces of the coastal rocks and transport the broken pieces towards the sea. The forward and backward movement of seawater with these tools of erosion also cause corrosion of rock. 14. Environmental geology. Face and the floor. Abrasion is the actual physical breakup of cohesive rock similar to quarrying, in which sea cuts into unconsolidated materials and pulls away particles pieces. Attrition. It is the mechanical process in which waves cause rock fragments to collide with each other and progressively grinding and chipping each other into smaller, smoother and rounder pieces. The rock fragments become very small that they are easily transported towards the sea by rip currents. Hydraulic action. The coastal rocks are eroded even without the presence of rock fragments in the seawater. Waves erode the rocks when they continuously strike against them and the impact is powerful enough to break and disintegrate the rocks. Shock pressure of breaking waves. When waves strike against the coastal rocks, they exert enormous pressure particularly on the rocks' joints and cracks. Hence, the air trapped inside the rocks becomes compressed. With retreat of the waves, the pressure suddenly falls and the air expands. It causes stress in the rocks resulting into weakening of the rocks surrounding the air pocket leading to their exploding and breaking along the joints and cracks. Besides the mechanical process, solution activity also increases in the soluble rocks. In the process of solution, acids contained in the seawater dissolve some types of rock such as chalk or limestone. There are several features that develop due to erosion. Some of the common features are described here. Cliff and notch. Rocky coast vertically rising above seawater is called cliff, figure 6. Steepness of the cliff is determined by types of rocks, inclination of the rock strata, geological structure and relative rate of cliff face and erosion of base. Softer sedimentary rocks are comparatively easily eroded than hard and resistant rocks such as igneous and metamorphic rocks. Bedding plains and joints are the weaker zones along which the rocks break easily. If the rock strata and the joints both are inclined towards the sea, then the rocks easily break. Degree of steepness of the rock strata also enhances the rate of erosion. If the rate of erosion of the cliff face is faster than that of the cliff face, then overhanging cliff with steep vertical face is formed, whereas if the rate of erosion of the cliff face is faster than that of the cliff base, then verticality of the cliff disappears. When the waves erode at the base of the cliff, the feature thus developed is called notch, figure 6. 15. Environmental geology. Figure 6. Shore profile showing erosional features such as cliff, notch, wave-cut platform and wave-built terrace. Wave-cut and wave-built terraces. Base of the coastal rocks are eroded due to hydraulic action and a notch develops near the high water mark. This undercutting process causes the notch to become big and the upper parts to collapse over time. Such a resultant feature is called wave-cut cliff, figure 6. With continuous wave erosion and retreat of the cliff, a shallow shelf called wave-cut terrace, bench platform or shore platform develops, which is a flat erosional surface in front of the wave-cut cliff, figure 6. Much of the materials eroded by waves is moved seaward and is used to develop an underwater delta-like feature called wave-built terrace platform, figure 6. Headland. In the coasts with alternating soft and hard rocks, parts of the coast containing softer rocks are eroded fast due to differential erosion. This results in a point of land consisting harder rocks that extends into open water. The remnant feature is called headland, figure 7. 16. Environmental geology. Figure 7. Donapala Headland, Goa. Source: cave, blowhole, arch and stack. Cave is formed due to continuous wave erosion of the coastal rocks. When the waves strike the caves, it may develop a hole in the roof through which seawater sprays. It is called blowhole. At some places, a bridge-like feature called arch is formed due to wave erosion on both sides of headland. With continuous erosion over time, the arch collapses, causing separation of one end of the arch from the mainland. Such remnant isolated small island-like feature occurring just offshore is called stack. 5.2 Mechanism of transportation. The eroded materials, e.g. sands, silts, gravels, pebbles, cobbles and even boulders, are transported by waves and currents. The eroded materials are transported seaward by backwash and undertow currents that move from coast to seaward. These materials are again picked up by breaker waves or surf currents that bring the materials back to coast. So, the material is transported from coast to seaward and from sea to coastward. Majority of the transportation takes place by movement at the bottom and the surface is continuously modified. Longshore currents also transport the materials but parallel to the shoreline. Transportation takes place by one or more of the 5 transport mechanisms, i.e. suspension, rolling, sliding, saltation and solution is in rivers. The materials are sorted by the seawater as it carries and transports them. The finest particles are carried away farthest and the coarser particles are left behind on the beach. The materials in solution are carried farther off either by reacting among themselves or by organisms, animals and plants that extract some of the dissolved matter to build their shells or tissues. 5.3 Depositional processes and resulting landforms. The transported materials are deposited either in shallow waters near the shorelines in continental shelf and slope or in deep seas on the floor of the deep oceans. The common features developed due to depositional processes on coasts include beaches, spits, bars and barriers, lagoons, coastal dunes, mudflats, tidal marshes, wave-built terrace platforms, etc. Beach. The striking coastal depositional feature is the beach that occupies edge of a shoreline, figure 8 to 10. Beach is a product of sediment deposition due to reduced wave energy. The sediments are derived from different sources such as erosion of cliff rocks, or brought by rivers and or picked up by waves from the seafloor and moved shoreward. Beaches. 17. Environmental geology. Are formed in areas where either cliffs is either absent or not in direct contact with the wave-cut platforms. Beach is a gently sloping feature and in profile it slopes towards sea, but the gradient changes at different places. Shape of beaches could be either straight or concave. Most of the world's beaches are formed by sand deposition. Such beaches generally appear dazzling white. However, in the areas of high energy the beach material could be pebbles or even boulders. Spit and Tombolo. Spit is a ridge of deposited sediments that extends from land to sea, cutting off a portion of water from the open sea and is generally elongated in shape, figure 8a. It generally extends as a continuation of a beach in the direction of sediment transport due to longshore drift and is composed primarily of sand. Spit could be of different sizes and may take various shapes. A growing spit that connects the mainland with an island or an island with another island is called Tombolo, figure 8b. This is formed by deposition of sediment, primarily sand, due to wave refraction around island. B. Figure 8. A beach. B. Spit. S. Barrier island by mangrove swamp. M. Source. And B. Tombolo connecting the tide island located in lower center with the North Sink island in A and N. The white linear features bordering the islands are beaches. Source. Bars and barriers. Bar is a submerged depositional mound or ridge, which is generally composed of sand and gravel. Formation of a bar depends on currents and supply of sediment. At some. 18. Environmental geology. Places, due to local geology, a long, narrow island composed of sand and gravel is formed parallel to the shoreline. Such a feature is called barrier island, figure 8a. It is separated from the mainland by a lagoon, tidal flat or salt marsh. Barrier island and coral reefs may also create a lagoon, which is a quiet water area behind a barrier island or reef. In some cases, spits may extend right across the small bays or mouth of rivers forming a lagoon. Tidal flat and salt marsh. Tidal flat is not actually flat, rather a very gently sloping sandy or muddy area that is exposed during low tide and inundated with water during high tide. Based on composition of the materials it is either called sand flat or mud flat, figure 9. Salt marshes are the flat wet tracts which are located in the upper intertidal area. They are marshy area that are flooded by seawater during high tide. Tidal waters enter tidal flats through tidal inlets, which are also known as creek, figure 9. Figure 9. Mangrove swamp M, sandy S, and muddy tidal flats MF, and creek C, also known as tidal inlet, as seen in Pirodan Island, Gulf of Kachach. Source. V. Mangrove swamp. Another feature built by biological activities is the mangrove swamps, figure 8 and 9. Mangroves are evergreen halophytic vegetation that grow on soft muddy bottom on tropical coasts. Mangrove plants can cope up with high salinity and anaerobic soil conditions and have developed characteristic adaptations such as vivipary, i.e. breathing roots. V. Coral reefs. 19. Environmental geology. The biological structures built primarily by corals and algae along with a number of organisms are called coral reefs. Corals can grow in specific environment and hence are found in the tropics. Coral organism called polyp has exoskeleton of calcium carbonate. Corals grow in colonies and together build huge structures over a period of time. In India, coral reefs occur in a variety of settings at different places, i.e. Gulf of Kachach, Gulf of Mannar and Palk Bay, off Malvan Coast in Maharashtra, Lakshadweep and Andaman and Nicobars. There are primarily 3 types of coral reefs. Fringing reef, that grow next to land. Barrier reef found at some distance away from the coast and separated by a shallow lagoon. Atoll near circular or elliptical reefs that are characterized by the presence of a central lagoon, figure 10. Figure 10. An atoll type of coral reef in Lakshadweep with characteristic central lagoon. The island visible is the Chetlat Island. The wild line surrounding the island is beach. Source. V. Coastal dunes. 20. Environmental geology. Dunes are generally found at the back of beaches. Like the dunes developed in deserts, they are wind deposits varying in size and morphology. They are best developed in the areas of wide beaches with abundant supply of fine sand and presence of low vegetation at a short distance back of the beach along with strong wind. Coastal dunes may be of several types as in the desertic dunes such as parabolic dunes, barchans, transverse, longitudinal dunes, etc. V. Delta. The area where a river meets sea is called estuary. The sediments brought by river may get deposited at the mouth of the river where it enters sea. Shape of such deposits generally resembles Greek letter delta. Delta, hence such features are called delta, figure 11. Figure 11. Delta formed on River Krishna, source, hash. 6. Types of coasts. Coasts can be classified based on its relation with sea level, such as emergent or submergent, or by the nature of material such as rocky or non-rocky coasts. Non-rocky coasts can be further classified as sandy, muddy. 6.1 Basis of classification. Several classifications have been proposed for classifying coasts based on numerous factors, however, no classification has found universal acceptance. We shall discuss here some of the parameters on which classification of coasts have been proposed. I. On the basis of sea level fluctuations with respect to land. 21. Environmental geology. Classification by D. W. Johnson, 1919, is one of the commonly used which is based on the sea level fluctuations in relation to the land and categorized shorelines into following 4 types. A. Shorelines of submergence. These are formed by partial submergence of land due to rise in sea level or subsidence of the land and are characterized by features such as cliffs, wave-cut platforms, caves, headlands, offshore islands, drowned valleys, deep embayments, etc. B. Shorelines of emergence. These are formed by upliftment of land or lowering of sea level and are characterized by features such as relatively straight coasts of low relief, marine terraces, offshore bars, lagoons, etc. C. Neutral shorelines. These are having characteristics which are independent of submergence or emergence, e.g. delta, volcanic shorelines, coral reefs. D. Compound shorelines. These shorelines include more than one type mentioned above, e.g. marine terraces and drowned valleys. E. On the basis of shoreline maturity and the nature of agency. Although Johnson's classification is simple and genetic in nature, there are several limitations of it, such as emphasis on sea level change. Many shorelines have undergone both submergence and emergence due to Pleistocene glaciations and interglaciations, and nearly all shorelines are compound. Considering the limitations, Shepard 1937, 1948, 1963 proposed twofold classification which is based on shoreline maturity and the nature of agency. A. Primary or youthful coasts. These are formed primarily due to non-marine terrestrial agencies and include subtypes resulting due to erosion on land and drowned subsequently, deposition on land by river, glaciers, wind, vegetation, etc., volcanic activity, and diastrophism. B. Secondary or mature coasts. These are formed mainly due to marine processes and include subtypes resulting due to marine erosion, marine deposition, and biological activities. E. On the basis of energy environments. A more useful classification has been proposed by J. L. Davies on the basis of energy environments. He recognized following types of environments. A. Storm wave environments. They are characterized by frequent destructive storm breakers. B. Swell environments. They are characterized by flat constructive waves. 22. Environmental geology. C. Protected environments. They are characterized by low energy conditions. IV. On the basis of plate tectonics. Another useful classification was proposed by Inman and Nordstrom in 1971, in which 3 categories of coasts are recognized based on plate tectonics. A. Collision coasts. They are active margin of a continent. B. Trailing edge coasts. They are passive side of a continental plate. C. Marginal sea coasts. They are separated from open ocean by island arcs. These are the first order features on which second and third order features are superimposed, producing local coastal morphology. Second-order features are up to 100 meters long, 10 meters wide and 1 meter high above the ocean floor developed on first-order features. Examples include deltas, coastal dunes, barrier beaches and lagoons. Third-order features are smaller ones such as beach face and longshore bars. 6.2 Classification of Indian coasts. According to Ahmad, 1972, Indian coasts can be categorized into following 7 types based on their morphological attributes. I. Andaman and Nicobar type probably represents promontories of the Arakan-Yoma system and is characterized by coral reefs. E. Deltaic coasts type comprises major deltas of Ganga, Mahanadi, Godavari and Kaveri rivers and is subject to modification by strong monsoonic currents and cyclonic storms. E. Depositional plain type is a product mainly of fluvial deposition covering eastward sloping coastal plain from Bay of Bengal to Cape Comorin except the beaches affected by deltaic deposition. IV. Malabar type is submergent in nature and having undergone recession in recent times and characterized by high relief and irregular terrain. V. Maharashtra type is submergent in nature caused by faulting having an irregular outline with steep rocky prominences and embayments. V. Gujarat type is a coast with shallow tectonic depressions characterized by gully erosion fronted by estuarine shore mudflats. V. Kathiawar coast type is compound in nature and represents features of both emergence, such as barriers and coastal dunes, and submergence, such as cliffs, estuaries and inlets. 7. Coastal protection. 23. Environmental geology. Erosion of coastal areas is a significant problem in many regions around the globe. To protect coasts and coastal structures from erosion, several types of structures such as seawall, breakwater, groin, also called groin, and jetties are used which act as sediment trap. Seawalls are generally used in the areas experiencing strong wave attack, which is an embankment of concrete, boulders or other materials, figure 12a. The seawalls either have concave face to deflect the force of the waves or sloping ramp that helps to dissipate wave energy. An offshore wall constructed parallel to shoreline to break waves is called breakwater, figure 12b. It is generally used to protect a harbor from waves and currents. Groin or groin is a short wall constructed with concrete or wood perpendicular to shoreline from coast to low water level to trap sand and build up a beach, figure 12c. There is generally a series of walls that prevent erosion by trapping the sediments in the direction of advancement of longshore drift. Sand accumulates on the upcurrent side of the groin in relation to the longshore current. Jetties are long walls extending from shore at the mouths of harbors, figure 12d. They are constructed of boulders to protect entrance of harbor from waves and current erosion and or filling with sand. A. B. 24. Environmental geology. C. D. Figure 12. Different types of structures built to protect coasts from erosion. A. Seawalls off Mundra Port, Gujarat. B. Breakwater off Gangavaram, Vishakhapatnam Port. A. P. C. Groins near Gopalpur Port, Odisha, and D. Jetties off Vishakhapatnam Port. 15.1 Introduction. Soils are limited non-renewable natural resources. Soils provide a base for food production, water and many ecosystem functions. Healthy soil is important for healthy life on Earth. The word soil was originated from the Latin word, solum, which means, floor. The global scientific community recognized the significance of soil and observed International Year of Soils in 2015. The predicted global population by 2050 raised an alarm to protect the soil and its resources from degradation. The soil is a component of pedosphere existing in the interface between atmosphere and pedosphere. The concept of soil formation is explained by pedology, and the influence of soil on plants and human beings is described by edaphology. Learn more. Pedology, derived from Greek word pedon which means soil or earth, is a branch of soil science that deals with soil genesis, classification and mapping, whereas edaphology, derived from Greek word edaphos that means soil or ground. 5. Environmental geology. 15.2 Definitions. We have learned in lower classes that the soil is a visible surface of the earth which is loose in structure and formed from rocks and minerals by weathering process. Some of the definitions given by scientists are as follows. According to Whitney, 1892, soil is a basket of nutrient that supplies all the nutrients for plant growth. According to Hilgard, 1892, soil is more or less a loose and friable material in which plants, by means of their roots, find a foothold for nourishment as well as for other conditions of growth. According to Dokuchayev, 1900, Russian scientist, father of soil science, soil is a natural body composed of mineral and organic constituents, having a definite genesis and a distinct nature of its own. According to Joff, 1936, soil is a natural body of mineral and organic constituents differentiated into horizons usually unconsolidated of variable depth which differs among themselves as well as from the underlying parent material in morphology, physical makeup, chemical properties and composition and biological characteristics. According to Jenny, 1941, soil is a naturally occurring body that has been formed due to combined influence of climate and living organisms acting on parent material is conditioned by relief over a period of time. According to Soil Science Society of America, 1970, soil is the unconsolidated mineral matter on the surface of the earth that transformed by eugenic and environmental factors of parent material, climate including moisture and temperature effects, macro and microorganisms and topography, all affecting over a period of time and producing a product, that is, soil, that differs from the material. 6. Environmental geology. From which it is derived in many, physical, chemical, biological and morphological properties and characteristics. According to Dr. W. E. H. Bloom, soils not only serve for agriculture and forestry, but also for filtering, buffering and transformation activities between the atmosphere and the groundwater, protecting the food chain and drinking water against pollution and biodiversity. As soil provides nutrients, water, air and anchorage and supports life on Earth, it can be called a soul of infinite life, soil. By observing definitions of different scientific community, we can understand that the soils are four-dimensional open systems with time and space which connect to the atmosphere, biosphere, hydrosphere and lithosphere that are formed from mineral and organic substances on the Earth's crust by the effect of various environmental factors administered for long time. 15.3 Composition of soil. Soil is a major component of the environment and essential for existence of life on Earth. Soil is formed by the process weathering of rocks and by erosion. The soil forming factors and processes which influence the formation of soil is depicted in Fig. 15.1. Fig-15.1 Soil formation. 7. Environmental geology. The soil is made up of four major components like minerals, 45%, water, 25%, air, 25%, and organic matter, 5%. These will be discussed in detail in the preceding sections. These components influence the properties of soils. To understand the properties of soil, first we will go through the soil profile. 15.4 Soil profile. The soil has several layers beneath the Earth's crust. We will observe several layers in the vertical segment of the soil from the ground surface to parent material arranged in a sequential manner known as a soil profile. The main divisions in natural soil profile are known as horizons named as O, A, B. The main divisions in natural soil profile are known as horizons named as O, A, B, C and R. These natural layers or soil horizons are arranged parallel to the Earth's surface with non-uniform boundaries, different thickness and composition. These horizons provide information to pedologists to classify the soil in a particular location. The brief description of these horizons is here under. Horizon O. The O horizon represents soil layer which contains organic matter combined with minerals and clay. It is subdivided into two types. O1 It comprises of fallen leaves, twigs, lichens, and other decomposed plant and animal material which can be easily recognized. O2 It comprises of putrefied organic material that cannot be recognized. This horizon is observed in forest and wetland soils. Horizon O. The brief Horizon O. The O horizon represents soil layer which contains organic matter combined with minerals and clay. It is subdivided into two types. O1 It comprises of fallen leaves, twigs, lichens, and other decomposed plant and animal material which can be easily recognized. O2 It comprises of putrefied organic material that cannot be recognized. This horizon is observed in forest and wetland soils. Horizon A. It is the topmost layer of the soil and contains major portion of the organic matter with significant biological activity and fertile in nature. Because of this reason it is known as the biomantle, in which concentrations of all organisms of soil is more and bound to plant roots. This soil layer is suitable for cultivation. This layer is susceptible to leaching as the minerals and other soil constituents. 8. Environmental geology. Dissolve in rainwater and percolates downwards. Horizon A is subdivided into A1, A2 and A3 on the basis of their components. A1 It is dark in color due to the presence of more organic matter. It is rich in humus, which is a combination of decomposed organic matter, clay and a small portion of mineral content. A2 It is a lower part of the A1 horizon which is exhausted with reference to mineral oxides, clay and iron by leaching activity. Hence it is also known as alluvial horizon. It is rich in quartz and large size minerals. A3 It is an intermediate layer that connects A and B horizon with major characteristics of A1 and A2. Horizon B. The leached material like clay matter, oxides of iron, and aluminum from horizon are transported either by chemical or mechanical process and accumulated in this zone known as alluvial horizon, and the soil's accumulation is known as alpha sols. The presence of sesquioxides imparts dark red color to this layer. It is 8. Environmental geology. Dissolve in rainwater and percolates downwards. Horizon A is subdivided into A1, A2 and A3 on the basis of their components. A1 It is dark in color due to the presence of more organic matter. It is rich in humus, which is a combination of decomposed organic matter, clay and a small portion of mineral content. A2 It is a lower part of the A1 horizon which is exhausted with reference to mineral oxides, clay and iron by leaching activity. Hence it is also known as alluvial horizon. It is rich in quartz and large size minerals. A3 It is an intermediate layer that connects A and B horizon with major characteristics of A1 and A2. Horizon B. The leached material like clay matter, oxides of iron, and aluminum from horizon are transported either by chemical or mechanical process and accumulated in this zone known as alluvial horizon, and the soil's accumulation is known as alpha sols. The presence of sesquioxides imparts dark red color to this layer. It is subdivided into B1, B2 and B3. B1 It is an intermediate layer between A and B. B2 In this zone accumulation of leached material is at maximum in addition to the formation of sesquioxides in the zone itself. Since the accumulation of different components is high, the color of the zone is darker than other zones. B3 It is an intermediate layer that connects B and C with more similar properties of B2. The horizon A and B are together known as solum. Horizon C. This is the horizon of parent material from which the formation of soil starts. Along with the parent material, the other soils from A, B horizons containing carbonates or sulfates, calcium and magnesium translocated by natural process. Those soils have mixed properties of B and C and known as BC horizon. 9. Environmental geology. Horizon R. It is the hardest layer in all horizons, composed of bedrock by which all above layers are formed. 15.5 Properties of soil. The diverse nature of soil composition and its profile is not uniform on the Earth's crust. To understand its uses, effects on the environmental habitat, its resources and its health, it is necessary to learn the properties of soil. Testing of soil suitability for particular use. These properties provides ample information to the pedologists. These properties are governed by parent material, topography and soil formation factors. The properties are grouped under two categories. They are I. Physical properties. E. Chemical properties. Physical properties. Physical properties of the soil mainly deal with the color, soil texture and structure. These properties depend on mineral composition, amount and size of the particles. Dear learner, we will discuss about some of the important soil physical properties. They are 1. Color. 2. Texture. 3. Structure. 4. Density. 5. Porosity. 1. Color. It is an important and basic property to understand the classification of the soil. The change in the color of adjacent soils reveals about whether the soil formed from its parent material assigned as lithochromic or imparts the color in development process known as pedochromic color. Factors that influence the soil color are presented in Table 15.1. X. Lithochromic color. Red soil evolved from red sandstone. Pedochromic color. Red soil developed from granite stone. 10. Environmental geology. Table 15.1 Factors that influence the soil color. Soil constituents and process color. Organic matter black to dark brown, iron compounds red, brown. Soil constituents and process color. Organic matter black to dark brown, iron compounds red, brown and yellow, silica and mixture of other compounds white, light color, mixture of oxides of iron and organic matter brown, mixture of compounds of iron and manganese in alternate wet and dry conditions. Mottled color. Oxides of iron due to oxidation and reduction, bluish greenish color. 2. Texture. Soil texture is a combination of sand, silt and clay particles in relative proportions that can be determined by quantitative analysis. It is a basic property of a soil that cannot be altered in a given sample area and collectively known as soil separates, which can be defined by its size. There are several organizations that have established the size limits of these particles and classify the soil types into different categories. For example, the American system developed by USDA, the English system or British system BSI, the International system ISSS, and the European system Table 15.2. When the soils are wet, clay soils sense sticky, sand soil sense gritty and the silt sense smooth. The nature of soil separates presented in Table 15.3. 11. Environmental geology. Table 15.2 Naming of soil separates by different organizations. No soil separates. 1. It is composed of quartz in major portion and feldspar, mica, zircon and other heavy minerals. It is composed of phyllosilicates, metal oxides, organic matter with water depositions. It is also known as rock flour or stone dust. It is composed of quartz and feldspar. 2. It has consistent dimensions. Particle size is less than 0.002 millimeters. It has the particle size between sand and clay. 3. Spherical in shape, needle or plate-like shape. 1. It is composed of quartz in major portion and feldspar, mica, zircon and other heavy minerals. It is composed of phyllosilicates, metal oxides, organic matter with water depositions. It is also known as rock flour or stone dust. It is composed of quartz and feldspar. 2. It has consistent dimensions. Particle size is less than 0.002 millimeters. It has the particle size between sand and clay. 3. Spherical in shape, needle or plate-like shape. Spherical in shape. 4. Smooth, rough surface, very smooth with high specific surface area. Smooth surface and coated with clay. 5. Poor water holding capacity and high infiltration rate. Lower infiltration rate with high water holding capacity, fertile and sufficient moisture holding capacity for plants. 12. Environmental geology. Soil texture is an important tool to guide for soil management methods and provides the value of the land. It also provides the information about percolation and water holding capacity. 3. Soil structure. The structure of the soil provides information about the condition of the soil and various activities like movement of quantity of air and water, bacterial activity that occur in a particular soil. Soil structure is defined as the systematic arrangement of primary particles of soil like sand, clay and silt and secondary particles like group of primary particles combined to form granules or aggregate particles is known as soil structure. The primary soil particles are solids and the secondary particles are porous, spongy and are not solids. Majority of soils are combination of individual single particles and aggregate particles. Primary soil particles are structureless in nature whereas secondary particles are granulated structure. The aggregates or secondary soil particles are formed by the joining of individual primary particles with colloids of hydroxides of aluminium, oxides of iron, clay and decomposed organic matter by dehydration process under pressure. Significance. Soil structure plays important role in water infiltration, aeration, bearing moisture, fertility and also to resist the erosion. Learn more. There are 2 ways that bacteria could be involved in soil aggregation. 1. By producing organic compounds called polysaccharides. Bacterial polysaccharides are more stable than plant polysaccharides, resisting decomposition long enough to be involved in holding soil particles together in aggregates. 2. Bacteria are involved in soil aggregation is by developing a small electrostatic charge that attracts the electrostatic charge on clay surfaces, bringing together small aggregates of soil. 13. Environmental geology. 4. Density. The density of the soil is defined with reference to the solid particles as the weight per unit volume of the solid portion of soil is called particle density or true density. The bulk density of the soil is defined with reference to dry soil as the weight of dry soil per total unit volume. This total unit volume is the combination of solids and pores that contains air and water. The particle density of the soil may vary on the basis of the presence of the constituents. High density is observed in soils containing heavy minerals and decrease in soil density observed in soils with more organic matter. The bulk density decreases with increase in the fine texture of minerals in the soil. The bulk density provides the information about the porosity of the soil and useful to understand and estimate the physical behavior of the soil. 5. Porosity. Porosity is the space between the primary particles and between or within the aggregates which will be filled with air and water. The larger pores are termed as macropores or non-capillary pores, greater than 0.05 mm, and smaller pores are known as micropores or capillary pores, less than 0.05 mm. The soil air is inversely proportional to the soil water since water displaces air in the soil. The size of the pore spaces depends on soil texture, soil structure and vegetation. Air movement and water percolation is high in the presence of macropores and low in case of micropores. Chemical properties. pH. pH is the number of hydrogen ion concentration or the number of hydroxyl ion concentrations, which is a measure of acidity and alkalinity of a particular compound. When the hydrogen ion concentration is more, the soil is acidic. If the hydroxyl ion concentration is more, the soil is basic or alkaline. A logarithmic pH scale ranges from 0 to 14 is used to measure it. The pH greater than 7 indicates alkaline and the pH less than 7 indicates acidic soils. In natural soils, the mineral composition of the parent matter, weathering reactions and the temperature influence the pH values. In warm and humid climatic conditions, weathering reactions are high and acidification of soil predominates, whereas dry climate favors neutral or alkalinity of the soil. 14. Environmental geology. Significance. The pH the soil provides the information about availability of certain plant nutrients, water quantity and the suitability of the soil for different plants. Ion exchange capacity. Soil colloid particles like clay, sesquioxides and organic matter protect and preserve the essential plant nutrients from leaching. These nutrients will be taken up plant roots as and when required. The soil colloids filled with the nutrients are referred as colloidal bank. These nutrients present in the form of charged ions. The soil colloids at temperate regions have negative charged nutrients which adsorbs cations. In tropical regions, soil colloids adsorb anions. These exchange of ions between phases of solid-liquid, solid-solid or liquid-liquid is called as ion exchange reaction. If the cations are exchanged, it is called cation exchange reaction, whereas anion is exchanged, that is known as anion exchange reaction. The capability of holding exchanged cations, positive charged ions, is known as cation exchange capacity, CEC, whereas anion, negative charged ions, holding ability is referred as anion exchange capacity, AEC. CEC increases with increase in pH, whereas AEC increases with decrease in pH. Units to measure CEC is cmol P plus per kilogram. AEC is cmol E per kilogram, which denotes centimoles of charge per kilogram. Examples of cations: Ca2+, Mg2+, K+, NH4+, H+, and Na+. Anions: SO42, Cl, PO43 and NO3. The relative order of cation exchange is H greater than Ca greater than Mg greater than NH4 greater than K greater than Na. Anion exchange is O greater than H2 PO4 greater than SO4 greater than number 3 greater than Cl. Significance. I. This is the only process for plants to take up the nutrients from the soil. E. It provides the information about the soil fertility. E. It provides the information about availability of nutrients and need of the fertilizers. 15. Environmental geology. 15.6 Soil is a resource. Soil is a non-renewable resource for land use, agricultural productivity and ecological services. In this chapter we are going to discuss about some important soil resources. 15.6.1 Resource for mineral. So far we have learned that the major part of the soil composition is by minerals. Now we will discuss about the mineral resource in detail. Minerals are crystalline natural inorganic constituents of rocks with uniform chemical properties. The minerals are the product of the solidified liquefied magma. The fundamental unit in the mineral is silica, CO2, since the high abundance of oxygen and silica on Earth. The classification of minerals can be studied on the basis of their composition and crystal structure. They are: I. Silicate minerals. E. Non-silicate minerals. Silicate minerals. Silicate minerals are rock-forming minerals and consist of silicon and oxygen atoms bonded by tetrahedral geometry. The basic atomic structure of silicate mineral is CO4, 4, and the silicon atom is placed at the center of the tetrahedron and the four corners are occupied by oxygen atoms. The remaining negative charges on the tetrahedron are balanced by suitable cations like sodium, Na+, potassium, K+, magnesium, Mg2+, iron, Fe2+, aluminium, Al3+, and water molecules or with other oxygen atoms of another silicate unit to get the stability. The silicate minerals are subdivided into 6 groups on the basis of their structure and bonding of oxygen and silicon. Table 15.4. Table 15.4 Types of silicate minerals. No structure name of the group example. 1 tetrahedral ortho or neosilicate olivine, 2 double tetrahedral cerosilicate epidote, 3 ring cyclosilicate beryl, 4 chain single and double inosilicates pyroxene and amphibole. 16. Environmental geology. 5 sheet phyllosilicate clay, mica, 6 3-dimensional tectosilicate quartz, feldspar. Ortho neosilicate. These minerals are formed of either Mg or Fe cations. These are also described as ferromagnesium minerals. Their color varies from dark brown, black and green due to the presence of iron and magnesium. The examples of ferromagnesium minerals are olivine, pyroxene and amphibole. These are categorized under different groups because of their structural differences. Olivine has a single tetrahedral structure in ortho, neosilicate structural group. Pyroxene and amphibole are grouped under chain structural group. Pyroxene has single chain structure in which 2 oxygen atoms shared in individual tetrahedron. Amphibole has double chain structure in which more than 2 oxygen atoms contribute to their structure. Augite is an important mineral found in soils and basic rocks as well under pyroxene group, which are basic in nature. The amphibole minerals are found in acidic rocks. Cerosilicate. These silicate minerals have double silicate tetrahedron structure that is linked by single oxygen atom. Epidote has the complex structure consists of chains of aluminium oxide tetrahedrons connected by single or double silicate tetrahedrons and generally exist in hourglass shape. They are rare minerals with 2:7 silicon oxygen ratio with chemical formula Ca2Al, Fe Al2O CO4 C2O7O. Cyclosilicate. These mineral tetrahedrons are connected in ring structures with 1:3 silicon oxygen ratios. The important cyclominerals are beryl and tourmaline with chemical formulas B3Al2C6018 and Nafe2 plus 3Al6C6018, Bo330-4. Phyllosilicate. Silicate clays are important class under phyllosilicates which have fill and leaf-like structure, leaf-like or sheet or layer-like structure. Examples are clay silicates. These clay silicates are formed by either alteration or weathering process of various mineral rocks. These are 2 types of K silicates, silica tetrahedron and aluminium or magnesium octahedron, that are arranged in horizontal manner. Both the silicate sheets are held together by sharing oxygen atoms. 17. Environmental geology. Within the crystal structure. Depends on the arrangement of tetra and octahedral sheets. They are classified into 1 type, 1 type and 1 or 2 type clay minerals. Clay minerals are extensively used in manufacture of ceramics and in construction. Feldspar. 3-dimensional silicate minerals. Feldspar and quartz belong to tectosilicates that have 3-dimensional tetrahedral structures. Feldspars. The gaps of the tetrahedrons are filled by K+, Na+, Ca2+, or Al3+. Potassium feldspar, also known as orthoclase, sodium feldspar known as albite, and calcium feldspar anorthite are the important types which are rarely found in rocks. There are series of silicates observed in between albite and anorthite known as plagioclases. Feldspars are used in ceramic making. 18. Environmental geology. Quartz. It is the best known mineral of the silicate. It occupies 12% of the lithosphere by composition. The general formula and the simplest of all silicate minerals are CO2. It is very hard and weathering resistant than their layer counterparts. The modified quartz is cristobalite, opal, tridymite. The pure quartz is used in the glass manufacture and in construction. Non-silicate minerals. Non-silicate minerals are mostly recognized by their respective anions. Examples of carbonate minerals are calcite, that is calcium carbonate, Ca3, dolomite, that is calcium magnesium carbonate, CaMg, CO3, 2. The important and widely used sulfate mineral is gypsum Caso 4.2H2O. It is also known as plaster of Paris, used in plasters making. Minerals also available as sulfides like pyrite, Fe2, is known mineral which is called fool's gold due to its metallic golden color. Other examples are PbS and ZnS that are important sources of lead and zinc. Hematite Fe2O3 and magnetite Fe3O4 are common iron ores. Halite, sylvite and fluorite are the examples of halide mineral. 15.6.2 Resource for water. 1/3 of Earth's surface is covered with water in various bodies. Out of it, 30% is groundwater, which includes soil moisture and wetlands. Now we will discuss different types of soil water in detail. The free water which found in large soil pores drained rapidly by gravitational force and is not available to plants and reduces the oxygen supply is known as gravitational water. The water in capillary soil pores which held by cohesion and adhesion forces against gravitational pull that is available for plants is known as capillary water. Some of the soil water found in the form of vapor on the surface of soil colloid particles is known as hygroscopic water. Significance. Soil water is responsible for plant growth and acts as solvent medium for transportation of plant nutrients. It regulates the soil temperature and assists the biochemical activities of the soil. 15.6.3 Resource for fossil fuels. Fossil fuels are energy sources like solid fuels, coal, natural gas and oil that are formed by the buried decayed organic material from plants and animals which were converted by physiochemical processes, anaerobic decomposition, over millions of years. Natural coal is considered as sedimentary rock which is formed in swamp soils. The anthracite is a harder form of the coal that is transformed at high temperature and pressure, which is considered as metamorphic rock. It is composed mainly of 19. Environmental geology. Carbon and other elements like oxygen, hydrogen, nitrogen and sulfur. Natural gas is a gaseous hydrocarbon mixture, mainly contains methane and trace amounts of CO2, N2, H2S and He. The crude oil is a mixture of liquid hydrocarbons and sulfur compounds present in micropores of sedimentary rock. Bituminous and oil shales are other fossil fuels under the soil. 15.6.4 Resource for raw material. Soil is a main source for raw materials that are used in modern appliance manufacturing. For construction of brick-walled houses requires clay, and plinthite is a raw material for making bricks. Clay and loamy soils used for plastering, sand and gravel used to concrete by mixing with cement. Tin, asbestos concrete are used in construction of roof is obtained from soil. Pisolithic gravel is used for road construction. Rocky soil is used in final coating of dam walls. Raw material like soda lime and quartz are used to make glass window panes and doors. The daily usage products like toothpaste, body creams and lotions and talcum powder requires clay minerals. Cooking gas, fuels are also the examples of the soil raw materials. In this way the life of the human community is highly dependent on the raw materials acquired from the soil. 15.6.5 Resource for organic matter. Soil organic matter mainly composed of living soil organisms, decomposed plant and animal material that transformed into new organic substances and humus. It occupies 1-5% of solid portion of the soil and plays a major role in its structure and physico-chemical and morphological properties. It is the main source of soil nitrogen and other nutrients like sulfur and phosphorus. It is an important source of energy for microorganisms. It controls the nutrient cycling, provides food for soil organisms. Soils with high organic matter have more water holding capacity with decrease in leaching of nutrients and erosion than the low organic matter containing soils. Along with the organic matter, humus helps in absorbing nutrients and water that available for plants and also to improve the soil structure. 15.6.6 Resource for biological habitat. Physico-chemical process of soil was affected by the number of microbes and vertebrates present in the soil. They directly influence the soil fertility. Soil animals like mice and mile burrow the soil and redistribute the material of the soil from deeper layers to the surface. Earthworms, termites and ants also burrow and provide soil nutrients. Fungi help in decomposition of organic material and the formation of humus. Microbes like bacteria, algae, nematodes. Actinomycetes provides a gene pool in which actinomycetes provides earthy aroma when 20. Environmental geology. It's rain and contains antibiotics for human consumption. The other antibiotics isolated from the gene pool are glycopeptides, tetracycline and cephalosporin. These microbes also help in developing the genetically modified crops. Rhizobium, nitrogen-fixing bacteria in legumes and cyanobacteria or actinomycetes in non-leguminous plants is useful in nitrogen fixation. 15.6.7 Resource for archaeological materials. Soil is a natural physical and cultural heritage in terms of human revolution by storing archaeological remains. Soil properties are important in deciding the buried objects. Wooden objects decay due to the organic nature of the soil but can sustain in dry environment or underwater. Metal objects like weapons, ornaments and coins sustain for longer periods under aerated environment. Acid soils vigorously decompose iron artifacts. Objects like ceramics, pottery and glass sustain in all soil types. Fossils under the layers of soil provide the information about climate, agriculture and cultural variation of that particular region and time. The archaeological evidences like bones, tools, metal sculptures and remains of pottery, utensils under the soil indicates about the environmental quality, paleontological characters of human civilization and soil age as well. These evidences provide the information to understand the culture of human civilization. For example, the existence of Indus Valley civilization is evident at Mohenjo-Daro and Harappa by excavations. 15.8 Conclusion. Soil is an important non-replenishable natural resource which provides life support, food production, recycling of essential nutrients on Earth. Soil profile and soil structure shows the soil's ability of self-purification and neutralization. It is an interface between atmosphere and lithosphere that connects various organic, inorganic and biotic components. Soil is an important natural resource for minerals, organic matter, and raw material for industries that provides a flow of ecosystem services which are key factors to support human life and economic well-being. It is the human responsibility to conserve the soil in order to pass on to the next generation for their food, fodder and fuel security. 21. Environmental geology. 15.9 Keywords. Soil is an independent dynamic terrestrial system of nature that acquires properties with the forces which act upon it. Soil profile, a description of naturally formed layers within a soil, resources, biotic and abiotic factors that are consumed by organisms. Parent material, rock material whose weathering and gradual breakdown is the source of the mineral portion of soil. Oil shale, a natural sedimentary rock that contains kerogen, a material that can be extracted and refined into oil and oil products. Capillary water, water that clings in small pores, cracks and spaces against the pull of gravity. Fossil fuels, energy sources like crude oil, coal and natural gas that are derived from the prehistoric photosynthetic production of organic matter on Earth. 15.10 Reference